Good evening, good afternoon, good morning to everyone there. It's nice to be in ICC again. My name is Patricio Winckler. I'm from Chile, Valparaíso. There you can see a photograph of the main port of the city. And today I'm going to be talking about the impacts of climate change in operational downtime, and also on the combination of sea level rise and extreme waves in infrastructure of these facilities. And this work has been done together with Oscar Melo, an economist, who helped us to evaluate the costs of operational downtime, and also Cesar Esparza and Javier Amora, ocean engineers who work in the wave modeling of future scenarios. Well, first, I'd like to say that Chile is a 4,200 kilometer long country here in the Pacific coast of South America, and transverses lots of wave climates from very energetic regions in the south to more mild wave conditions in the north. And we are also affected by earthquakes and tsunamis, so multi-hazard analysis is something very important in this country. In this particular work, I'm going to talk about downtime in some of these ports. So you see that these ports are very open to ocean waves, swells, and that has a very important impact in the operational downtime. So between 2008 and 2018, there has been more than 18,000 hours of downtime due to operational conditions in the country. That's a lot. Important, relevant economical impacts in the supply chain. And this has been discussed by, well, the Ministry of Public Work, Ministry of Transport, the Maritime Authority. And so the country is trying to cope with this issue. What we did was to generate wave climate for a mid-century projection. We're currently working for end-of-century projection, and we compared with an historical window, say of 20 years, both. We basically forced Wave Watch 3 with 6 wind fields and ice coverage in the Pacific Ocean for both this historical period between 1985 and 2004, and also for 2026 and 2045, which is the mid-century projection, as it's called in the literature. In order to evaluate the changes, what we did was to compute the temporal medians for each of these models, during 20 years. So what you see here, for example, is the significant wave height in the top left panel, significant wave height for the projection, and you see these strong gradients, especially in the study area here in Chile. And also we did that for historical period, and then we subtract both in order to compute the changes for this particular model. By ensembling all these results of the changes, we computed the change which we attribute to climate change. Well, the length of these two periods is not that much, 20 years. But the availability of wind models is scarce if you compare it with other variables. So these are some of the results we found. Here you can see the historical period and the projection and the difference between both for the study area between Arica and San Vicente. One of the outcomes is that the wave height will slightly increase, and the wave periods will grow a little bit, also marginally, and the wave direction will tilt to the south. And this is because all the climate system is moving southward here, and that's changing the direction and the characteristics of the waves. Now, if we go to the nearshore waves, what we did was to bring, with a fully spectral propagation, the wave climate from offshore locations at those yellow dots in the left-hand panel to each of these places which we analyzed, right? And then we were able to compute the wave climate at the entrance of each of the ports. So what we have here is the computation of the wave climate, for the 6 models. In the left panel, we see the historical period, and we see 6 models computed in the case of Valparaiso. We did this for the 8 ports, and then we computed the median. We have the historical period and the median, the black line there, also for the projection. And then in the right-hand panel, we see both medians for the historical and projection. And we show here the vertical lines. They show the limiting operational conditions. We chose those values after making a statistical analysis of the types of ships that are more frequent at each of the ports, and it resulted, the analysis showed that the post-Panamax of roughly 300 meter of length was the most representative one. So from the right-hand panel, we see that the changes in the downtime, which are shown there by those dashed lines, is not that much because both curves are almost overlapped for those significant wave heights. Yeah, this will bring us to the main conclusion of the study, is that the operational downtime won't change that much in the mid-century when compared to the historical period. Yeah, but in the same plot, we see that extreme waves, they diverge, and the future extreme waves will be much more intense than the ones we've had in the historical period. So from this analysis, we repeated the analysis for all the ports, and here what we see is the changes in downtime in terms of percentage at the center and in hours in the right for all the ports with different limiting conditions, 1.5 and 2.0. Those are the red and blue dots respectively. And what we see is that there is not significant trend in all the ports. This is pretty much dependent on the local conditions. So some ports will improve their operational conditions, like for example, San Vicente, yeah, here at the bottom. And some of them will worsen their operational conditions, like Antofagasta. In San Vicente, the improvement will be of roughly 80 hours, which is a couple of days within the year, which is not that much. Then we moved forward and computed the downtime costs by using only 2 charges. One was the charge for using the docks, and the other one was for cargo movement. With this with an economist. We didn't focus on the entire supply chain or the most immediate supply chain of the port. We just focused on the berth side. And to do that, we crossed the information of the changes in downtime with statistics of, for example, the average ship length overall, the number of berth sites at each port, the mobilized cargo, which we assumed was going to be the same in the future, which is a very weak assumption, but we didn't make any projection on the cargo, and also on the yearly operation time, which we obtain all of this data from statistics available at the provided by the Maritime Authority. What we did was to calculate extreme significant wave heights for different return periods. This is a slide showing the values of the significant wave height for both the historical period and also the projection for different return periods, and also the changes in terms of percentage, right? So what we see here is that, for example, in central Chile, where Valparaiso is, the increase will be up to 20%. And this is mainly because of the big gradients we have here in terms of climate, and those gradients are moving southward. Now, extreme waves, as computed before, are very variable and depend a lot on the performance of each individual model. So here you can see that the range of values obtained from different models make any use of, for example, the median by itself very weak. So this is not a robust estimation. This is just a first approach. And here we see in the right panel the big change in the particular case of Valparaiso that the significant wave height will experience as the century evolves. Well, the combination of both the mean sea level rise and the increasing in coastal storms will eventually increase the overtopping, and that's what we calculated here. We took the Owen's formula, a very standard formula. We assumed a certain type of breakwater with the slope and so on. Yeah. And we computed this formula for both the historical condition of waves, expressed in terms of the significant wave height and mean period, and also in the future, where the changes in mean sea level were included in the changes in the freeboard, right? So by comparing the overtopping in the historical and in the projection, which is what we have here locally calculated at each of the ports, we see that in some ports, the increase in overtopping will reach up to more than 100%. That's very important in terms of the consequences we expect. So overall, downtime will not change that much, but extreme conditions will cause an increase in overtopping and eventually in structural damage. So the port authorities and the Ministry of Public Works should take into account this in terms of their maintenance costs for the future, which will eventually be much more important than the ones they have currently. So we have worked in generating an early warning system, which use would be to have an estimation of the local conditions with 7 days in advance. Yeah, and this would allow the port operators to make early decisions in order to make a better use of the berth sites in advance and eventually deviate cargo to other ports or whatsoever. So that's it. I think I'm open to questions, and I'm glad to see you in Sydney in a couple of years more.